Hello and welcome back to Atomic Math. Today we're going to talk about partial fractions, which is the art of taking fractions apart. So we can easily expand an equation by using things like FOIL. For example, if we had this equation here, we can expand it to be 2x squared plus 7x plus 6. Now factoring the second equation to get back to the original form is a little bit trickier, but we can still do that. With fractions, we often use a common denominator to add multiple fractions together. So for example, if I had these two fractions, I would cross multiply and I would end up with this, and if I expanded it out, I would get this. So we can go forward quite easily. We can find the common denominator. That's pretty straightforward. But it would be much more difficult to take that equation and go back to this. Going forward is always easier than going backwards, just like walking. So when we want to take a fraction apart, we need to use a special type of factoring, and that is partial fractions. So let's take a look at the equation that we created there. We're going to try and get us back to where we started. The first thing we would want to do is we need to be able to factor that bottom into two or more terms. So let's pretend that we do not know where this came from. Looking at this denominator, I can tell that I'm going to have 2x plus something and then an x plus something. And once you use sort of your factoring methods, you'll find that it is 2x plus 3, x plus 1. The tricky part is getting it back to two separate fractions. So even though we don't know exactly what two fractions came together to create this, we do know that it must have had this form, something over 2x plus 3 plus something over x plus 1. Now we just have to figure out what a and b are. So if we take this denominator here and we multiply both sides by that value, we can bring that up and we're going to be left with this. We would have 5x plus 7, and then now we have to multiply the other side by our denominator. But you can easily see that this piece and this piece are going to cancel out. So we're going to be left with this. 5x plus 7 equals a times x plus 1 plus b times 2x plus 3. Now that we don't have to worry about it being in a fraction form, we can manipulate this a lot easier. So let's just start doing that. First, we're going to multiply through by a and b to expand this out. We end up with 5x plus 7 equals 8x plus a, 2bx plus 3b. Now, I want to kind of collect those x terms on the right. So I would have 5x plus 7 equals ax plus 2bx plus a plus 3b. So this piece here, this ax plus 2bx, that must equal 5x. Because that's the terms that have x in it. And then we also know that this 7 must be equal to this a plus 3b. So if we write that down and say 7 equals a plus 3b, of course we can represent a as 7 minus 3b as well. And then our second equation is going to be that 5x is equal to that ax plus 2bx. So now we have these two equations that we can use to solve for these two variables. This a right here, we're going to substitute that into this value. So we're going to have 5x is going to equal 7 minus 3bx plus 2bx. And if we multiply that out, we're going to end up with 5x equals 7x minus bx. And since we can factor an x out of the 7 and the b, we'll have 5x equals x times 7 minus b. Of course, now we can cancel those x's, and now we have 5 equals 7 minus b, and of course that means b equals 2. Now we can go back to our first equation and throw b equals 2 in and solve for a, which is now going to be 1. So that means that our a is 1 and our b is 2. So if we looked at what we started with and we said that it needed to have this form, now we have our a and our b, and so we can say that this must have come from 1 over 2x plus 3 plus 2 over x plus 1. And of course, this is indeed where this fraction came from. Hopefully that was helpful in breaking down partial fractions. Sometimes they can be a little bit more complicated, but this method is extremely helpful, especially when you're solving like integrals and you need to sort of break things apart into smaller, more manageable terms. So if you like this video, go ahead and hit like, and if you want to see more videos like this, hit subscribe, and I'll see you in the next video.